Welcome to my first video on solving limits. In previous videos, we've gone over what a limit is and when a limit exists, and now we're finally going to get into how to solve limits. So broadly speaking, there are three ways to solve a limit. The first way is known as the table method. I've also heard it described as solving limits numerically, so you might hear it both ways. Just know we're talking about the same thing. To be honest, I wouldn't recommend this method. It's clunky, it's cumbersome, it takes a while to do, and you ultimately arrive at just an estimate rather than an exact number. But it's useful to have in your back pocket in case you can't figure out how to do it another way. And my teacher taught it to me, and so I'm going to teach it to you. That way, if you see it on a test or something, you'll know how to do it. Before we dive into that, though, it's important to talk about what we mean when we say solving limits. So we've seen this a million times before. The limit of f of x as x approaches a equals L. So when we're talking about solving limits, we really just mean looking for that L, right? So we have the limit, we have some function, doesn't matter what, and we take the limit as x approaches something, right? Maybe as x approaches 4, and we're looking for what that limit is, and that's L. And that's what we mean by solving limit. The table method. It literally is just a table. Top row is x, and the bottom row is f of x. So remember before when we were learning limits, we looked at what happens when we approach a from the left and what happens when we approach a from the right, right? We're like, all right, so what's this function doing when x is a little bit less and a little bit greater than a? Is the y value, or the value of the function, is the y value approaching some number as x hones in on a? And so that's what this table method looks at. So we have a here in the center, and we look at a little bit less than a, and we look at a little bit greater than a, and we check to see what happens to the value of the function itself as x gets closer and closer to a. We're hoping that it's approaching some number, the same number, and if it is, that is our L. So let's dive into an example. Let's look at the limit as x approaches 2 of x minus 2 over x squared minus x minus 2. So what is that limit? Let's start by getting our x and f of x. So we're going to go a little bit less than a on the left and a little bit greater than a on the right. And in this case, a is 2. So we're going to do 1.9, 1.99, 1.999, 2, 2.001, 2.01, and 2.1, right? A little bit greater than a little bit less than a on both sides. So let's start by plugging in 1.9. So we're just going to plug in all these values and see what happens to our function. So let's plug it in. So 1.9 minus 2 over 1.9 squared minus 1.9 minus 2. What does that give us? That gives us 0.3448. And so we put that in the first cell right there. And we go to our second value, 1.99. And we do the same thing. This is just plugging and chugging right here. And this is just basic algebra. We're just plugging the numbers in for f and putting the answer in our table. So when we put 1.99 in, we get 0.3345. Okay, all right. So it's getting a little bit smaller. And now I'm not going to do this for every single value. That would take too long and that'd just be boring. So for 1.999, it is 0.3334. For 2.001, it's 0.3332, 2.01 is 0.3322, and 2.1 is that. So let's take a minute and look at this. So we start at basically 0.34, we go down, we get to 0.3334, and then we go to 0.3332. Well, right in the middle there, it looks like we skipped 0.3333, right? It looks like on both sides, the value of the function is approaching 1/3 as x is approaching 2. Right? Do you see that? As x is approaching 2 from the left, it's getting smaller towards 1/3, and then as x is approaching 2 from the right, it's getting greater and approaching 1/3. So, since both sides are approaching 1/3, that's our limit, 0.33333 repeating. We can say that the limit of x minus 2 over x squared minus x minus 2 as x approaches 2 is 1/3. And that's our answer. That's the table method. You see, it's kind of cumbersome, right? It's kind of a pain. There are easier ways to do it. It's important to know, though, that the table method, you're literally just looking at the left-hand limit and the right-hand limit. You're building a table to see what the value of the function is approaching as x is approaching a from both sides. I feel like a broken record saying that so many times because that's what a limit is. And with the table method, that is literally what you are looking at. It's just a basic calculation approaching a from both sides and seeing what the function outputs if the function is approaching a specific number. And in this case, it was approaching 1/3. Check out my next video. We'll get into the second way to solve limits. That one is really easy, very easy. Be a nice short video. You'll love it. Way more fun than this. But if you learned something, leave a like and subscribe, and I will keep the math content coming.